In this problem, we're going to be solving a value mixture problem using a system of linear equations. So the first problem we have is two mechanics worked on a car. The first mechanic worked for 10 hours, and the second mechanic worked for 5 hours. Together, they charged a total of $1,425. What was the rate charged per hour for each mechanic if the sum of the two rates was $180 per hour? Okay, so let's label some things here. We got X is equal to the first mechanic's rate, and Y is equal to the second mechanic's rate. Okay, so the first thing we notice is that it says the rate charged by each mechanic, the sum of the two rates is 180 per hour. So the sum of these two is 180. So X plus Y equals 180. And then we know we got charged a 1,425 for this many hours for mechanic 1 and this many hours for mechanic 2. So our second equation will be 10 hours for mechanic 1 plus 5 hours for mechanic 2, that's a Y, equals 1,425. Okay, so now we have two equations, two variables. We can solve this. So let's subtract the X here. Get Y is equal to 180 minus X. And I'm going to substitute that 180 minus X right there in place of Y. So that gives me 10X plus 5 times 180 minus X equals 1,425. Okay, if I multiply this all through, I get 10X plus 900 minus 5X equals 1,425. Combine my x's and move the 900 over, so I get 5x. If I subtract the 900, that gives me equals 525. And when I divide by 5, I get x is equal to 105. Okay, so the rate of the first mechanic is $105 per hour. To find the second one, we plug it in right here. So y is equal to 180 minus 105. So the rate of the second mechanic was $75 per hour. Okay, let's do another one. So this one has the Jones family and the Taylor family each used their sprinklers last summer. The water output rate for the Jones family sprinkler was 25 liters per hour. The water output rate for the Taylor family sprinkler was 20 liters per hour. The family used their sprinklers for a combined total of 40 hours, resulting in a water output of 875 liters. How long was each sprinkler used? Okay, so I will label J is equal to the total time for Jones, and T will be the total time, not times, for Taylor's. Okay, so we know that combined they had 40 hours, so J plus T equals 40. That's our first equation. Total time, add them up, you get 40 hours. And now let's do the rate. So the Jones was 25 liters per hour, so 25J. And the Taylor's family was 20 liters per hour, so plus 20T is equal to the total of 875 liters. Okay, so we'll solve this just like we did the other one. Oh, in fact, let's solve it a different way. So let's solve this one using elimination. We did substitution on the last one. So let's put this equation underneath there. J plus T is equal to 40. Let's multiply the bottom one by negative 25. Or actually, let's do negative 20. So we'll get rid of the T. So negative 20 so that we can get rid of that second variable. So 25J plus 20T equals 875. And then we have negative 20J, that's our second equation, minus 20T is equal to, let's see, negative 800. Now if we add those straight down, the T terms cancel, and we get 5J is equal to 75. So when we divide by the 5, we get J is equal to 15. So the total time used by the Jones family was 15 hours. And then we can go over here to this equation, plug j in there. So 15 plus t equals 40. If you subtract the 15 over, you get t is equal to 25. So 25 hours and 15 hours.